Good day and a very warm welcome to everyone. Today, we are pleased to present our mini project entitled Using AI to Calculate Final Purchase Amount in an Online Shopping System. This project was developed for the course BCI 1143 Problem Solving Semester 1 2025-2026. Our group is called CODE4CART. I am Bharati Mahendran, the group leader. My team members are Alia Inshira, Nur Adila Hayani and Nur Amali. In this presentation, we will explain the motivation behind our system, how it works and why it is useful in a real-world retail environment. For today's presentation, we will cover several important sections. These include early problem analysis, system input and output, real-life application, algorithm and flowchart design, test checking, C programming implementation, efficiency, sustainability, and key insight gained from this project.
Our project is based on a local retail shop that sells branded products such as Nike, Adidas, and Puma. Currently, the shop calculates the customer bills manually based on the number of items purchased and the customer membership status. Although this method works when the customer traffic is low, it becomes inefficient during the peak hours. Manual calculation increases the chance of errors, especially when the discounts are involved. As the result, customers may receive incorrect bills which can affect their trust in the shop. To solve this issue, the shop plans to implement the automated billing system that calculates the total amount quickly and accurately. The system requires several input to function correctly. This includes the customer's name, email, membership status, selected shop, and the item chosen along with the quantities. The system applies with two discount rules, which is first a quantity discount of 10% if the customer purchases 3 or more items, and the second one is membership discount of 15% if the customer is a registered member. By applying these rules, automatically the system ensures fair, consistent, and accurate billing for every customer. This slide shows a sample input and the corresponding output generated by the system. The system calculates the total price, check whether the customer qualifies for the discount, and then display the final payable amount. This clear breakdown helps both cashier and the customer understand how the final amount is calculated.
Our system is designed to be practical and flexible. It can be used by small retail shops that cannot afford advanced POS system. It is also suitable for SMEs, pop-up stores, bazaars, bookstores, and student shops. This business often rely on manual calculation, so our system provides a simple and cost-effective digital solution that improve efficiency and reduce errors. Without the automatic billing system, several problems may be happen. For example, checkout line will be longer, especially during busy period. Second, cashier might forget to apply discount or apply them incorrectly. Other than that, customer may become dissatisfied due to billing mistake because of staff workload and stress level will also increase.
The problem analysis chart, which is PAC, help us clearly identify the problem, require input, processing step, and also expected output. By using the PAC, it allows us to organize our task before writing the algorithm or code, reducing the confusion and also logical error. The interactivity chart, which is IC, show how different parts of the system interact with each other. It visualizes the flow of data and ensure that all the components work together smoothly. The IPO diagram summarizes the system into 3 main parts, which is input, process, and output. This structure helps simplify the complex logic and make the system easier to understand and implement.
Next, I will explain the algorithm used in our online shopping system. First, the system starts by asking the user to enter their name, email, and membership status. The membership status is entered as 1 for yes and 2 for no. After that, the system displays a shopping menu with 3 options: search by shop, search by item, and checkout. The system repeats this menu using a repeat until loop until the user chooses checkout. If the user selects search by shop, they can choose between Nike, Adidas, or Puma. Then the user selects an item and enters the quantity. The system calculates the total price by multiplying the item price with the quantity and update the total item purchased. If the user selects search by item, a general item list is shown. Again, the user selects an item quantity and the total cost and total item are updated. Once the user selects checkout, the loop stops. The system then checks if the total items are 3 or more and applies a quantity discount. If the user is a member, an additional membership discount is applied. Finally, the system calculates the final amount and displays the full bill summary before stopping the program. This slide shows the flowchart of our system. The flowchart begins with the start symbol followed by input symbol to read the user's name, email, and membership status. Next, the program enter a loop that displays the shopping menu. A decision loop checks the user's choice. If the user selects search by shop, the flowchart branches to shop selection and item selection, followed by price calculation and updating the total items. If the user selects search by item, the flow chart shows item selection and quantity input, then updates the total cost. If the user selects checkout, the flow moves out of the loop after checkout. Decision symbols are used to check whether the total items are greater than or equal to 3 or whether the user is a member. Based on this decision, discounts are applied. Finally, the system displays the final bill details and ends the program. Dash checking is done to manually verify that our logic and calculations are correct. In our sample input, the customer name is Farah with membership status yes. First, Farah selects Nike hoodie with a quantity of 2. The total becomes 500 ringgit and total items become 2. Next, she selects a T-shirt watch with quantity of 1. The total becomes 2,300 ringgit and total items become 3. Since the total items are 3, a 10% quantity discount is applied. Because Farah is a member, an additional 15% membership discount is applied. After subtracting all discounts, the final amount payable is 1,759 ringgit and 50 cents. This dash checking confirms that our algorithm works correctly.
This slide explains the module used in the flowchart and the parameter passed between them. First, the main module. It controls the overall program flow. It connects all modules and manages looping and decision making. Next, the read module. It receives input parameters such as the user's name, email, and membership status. Then, the display module. It receives the final calculated values and displays the bills of the user. By using separated modules, the flowchart becomes clearer, more organized, and easy to understand. Finally, calculation module. It processes the item charge, shop charge, quantity, total price, and total number of items. This module performs all price calculation and update the totals.
In this slide, we explain module and parameter based on the algorithm. First of all, the main module. This main module initializes variable and control program execution. Secondly, the read module. This module accepts user input such as name, email, and membership status. Other than that, the calculation module, which is calc module, it processes the shopping logic, which is receive parameter like item choice, quantity, total item, and update them accordingly. Next, the display final bill module, which is the output the final result including total item, total price, discount, and final amount. By using this parameter passing, we ensure that values are updated correctly between modules.
This slide shows the implementation of our system using the C programming language. We use standard input and output functions such as scanf and printf to interact with the user. A while loop is used to repeatedly display the shopping menu until the user selects a checkout. We use if-else statements and switch cases to handle shop selection, item selection, and discount calculation. Variables like total items, and discount are updated throughout the program. This slide explains the overall flow of the C program. The program starts with collecting user information, then it enters loop where the user can continuously add items to their cart. Based on user input, the program calculates prices and keeps track of the total items. Once checkout is selected, discounts are calculated according to the rules. Finally, the program displays a complete bill summary and an execution. This flow ensures accuracy, flexibility, and user-friendly interaction. Our system improves transaction speed, reduce errors, and allow better use of human resources. It also supports sustainability by reducing unnecessary paper usage and repeated billing correction. Through this project, we learned the importance of structured problem solving, strong logic, teamwork, and applying algorithm in real-world problems. In conclusion, our automatic billing system demonstrates how a simple, well-designed program can significantly improve retail operations. Thank you for your time and attention. We hope you enjoyed our presentation.